Hello again, CSI 135 students, and welcome to the video tutorial for lab number 5, and this is the solution set for lab number 5. Alright, I actually have the lab displayed in another window, and as you can see I have no mail, but if I wanted to go back and look at mail that I had read, I could type in mail space -f inbox, and this is mail that I haven't deleted but that has already been read. Right, and you can say here is lab number 5. So take a look at number 16, right? And here's the lab. And so I've got this in a different window, and we're actually going to walk through this. Oops, we're going to walk through this one by one. All right. It says, hello and welcome to lab number 5. This lab requires you to take all the knowledge and information you have learned to this point to accomplish a series of tasks that need to be completed on the class system Vader. As always, for any questions that require you to respond or provide an answer, you'll need to keep those responses in a file using the Vim or VI editor, and that file will be mailed to me at the end of your lab. You can name the file anything you would like and keep the file in any directory you desire. As long as you can email it to me, you're good to go. All right, on to lab number 5. So the first question says, for the following directories listed below, please provide the numeric representation of their permission settings. And so all the directories are in the /temp/permissions directory. And here they are, dir1, dir10, 2, 3, and so on. So for dir number 1, the permission set would be 7, 7, 6. And again, keeping in mind that the R has a value of 4, the W has a value of 2, and the X has a value of 1. And it's read, write, and execute. And again, as a reminder and review, the first 3 permission bits are for the owner of the file, in this case, TPB. The next 3 permission bits are for the group members for the file, which are members in the faculty group. And the last 3 bits are for anyone else or other. So read and write for others. Okay? So this one would be 776. Dir number 2, which is here. Whoops. Dir number 2, which is here, would be 706. And again, read, write, execute 7. Not on, and not on is 0. And then read and write is 6. Dir number 3 is simply 204. Directory number 4 would be 5, and then 2, and then 3. Directory number 5 would be 6, 6, 2. Directory number 6 would be 7, 7, 1. Directory number 7 would be 4, 4, 3. Directory number 8 would be 3, 2, 1. And finally, directory number 9 will be 2, 1, 7. And lastly, directory number 10 is 1, 7, 1. Right? So those would be the permission sets for all of the directories. Number 2 in the lab says, now, for each of the 10 directories you created in step number 1, you will need to provide a command for each directory. In other words, you're going to have 10 commands when you get done with number 2 that would have created the directories with the permissions you calculated in step number 1. The command, each time, needs to assume that the /temp/permissions directory never existed. Right? So you need to take into account the fact that the parent directory is not in existence. So you'll need to account for the creation of that directory at that time, and at the same time it needs to be one single command. Right? So if I were to type in mkdir/permissions/dir, and I'll use 01. Right, or I'll just say dir1. So this would create the directory if the permissions directory and the temp directory already existed. So we know the temp directory will be there, but we don't know the permissions directory is going to be there. In fact, the question asks you to assume that they are not there, right? So what you would need to do is you would need to use the -P option, right? And then you also want to use the mode option, which allows you to set the permission mode on the directory that you're creating. And so in this instance, dir1 is 776, right? And so that would be the command. And if I were to do a man on make dir, you can see sets the permissions, right? So the -M command sets the permissions. So let's run this command just for, let me pull that ls command back up here real quick. So if I were to do make dir /temp, and let's say I'll just call this let's call it dir1, right? And then if I were to do dir1, if I hit enter, you can see it says no such file or directory because dir1 in temp does not exist. But if I type make dir -P /temp /dir1 the command succeeds, because the -P says if the parent directory does not exist for the directory that you're trying to create, then create it. Directory, let's try directory number 2 now. So if I were to do make dir, and let's try, we'll make it directory number 3, and we'll see if it actually creates both the directory, dir3, and as you can see, it created it with 776, right? And it created the parent directory, which did not exist prior to me running this command. Okay, so basically you're going to have 10 commands that look just like this, right? That set the mode for each of those directories based off the permissions that were already there. All right, on to number 3. So it says there's a file located in the following directory: /temp /24 /the following /dexter /homeland. All right, so let's do an ls/lai because I want to see everything I can here, right? So I've got, excuse me, I have a file that's a question mark with a name. I have a file that has an asterisk as a name, a file with an ampersand that has a name, and a file that's with the name -rf. And it says your task is to provide a command that could be used to delete the file with the name -rf, right? So I can experiment on this. If I just created that directory dir1, right? Oops, lai. I could use the touch command with the -rf option. I'm sorry, use the touch command with the option and then give it the argument -rf, which is the file name. When I type ls-lai, you can see that I too now have a file with the name -rf. So if I type rm -rf, I can remove that file, right? So that's a great way to remove that, and that's actually the answer that we're looking for. All right, number 4 says, in the same directory as step number 3, provide a command that could be used to delete the file with the name asterisk. So simply the asterisk. So if I touch --asterisk and do an ls/lai, oh, whoops. Actually, for this one, we wanted you to use the, wanted you to do the v, oh, that's, hold on one second. I think we've got it there. There we go. So remember, you want to put the double quotes around it, right? So touch --, and then the double quotes, and that gives us a file with the name asterisk, right? So from here, to remove that file, I could type rm --, and the reason we put the quotes around it is because we don't want it to be interpreted as a special character. ls-lai, and that file is gone. All right. Number 5, in your home directory, create a directory with the name bin and change the directory permissions to 700. So, to get to my home directory, I use cd, enter, and now if I type pwd, you can see I'm clearly in my home directory, and let's see what we have in here. Do not have a file with the name of bin, or I'm sorry, directory with the name of bin. So I'll do a make dir, and I want to set the mode. So I'll do -- mode equal, and it wants us to do it at 700, right? So now if I do an lslai, you can see that here at the very top, I've created a directory with the name of bin, and that stands for binary, and the permissions are read, write, and execute. So 700. Okay. Question number 6 says, what is the value of your path variable? So there's a couple ways we can get this information. One of the ways is you can use the echo command, $path, and that would give it to us. And that's a little bit more advanced. The way we spoke of, or the way we talked about getting this information, was to simply do a more on your .bash _ profile, right? And as you can see, there's the value as well, right? Okay, so those were 2 ways that you could get that value. What is one reason, and the reason we have discussed, that will result in the following error message? If I try to type in make dir /temp/a/b/k and I hit enter, it says cannot create directory. So we talked about the fact that you need to make sure the parent directories exist. So temp/a/b/k, and I type enter, and now I no longer get that error message. Number 8. Using only the cat command, create a file in your home directory that lists out the first 10 American Idol winners. You can name the file anything you would like. Alright, so, and this is using the cat command, right? Excuse me. So I'm going to go to my home directory. I'll type pwd, and that'll confirm I'm in my home directory. So you'll remember that I could type cat all by itself and hit enter, and then if I were to enter in A and hit enter, it just echoes it back to me, right? So what we want to do here is we want to make sure. Okay, so now on to number 8, and it says using only the cat command, create a file in your home directory that lists out the first 10 American Idol winners. So we're going to go ahead and do American Idol winners. All right, so cat space greater than. So I'm redirecting the output of the cat command into a file called American Idol winners. Now if that file exists, it will be overwritten with the information that we are about to provide, right? If it doesn't exist, it'll be created. So I hit enter. I'll type in Kelly Clarkson, and then Ruben Studdard, and then Fantasia Barrino, Carrie Underwood, whoops, back up over that, Carrie Underwood, alright, and then after Carrie it was Taylor Hicks, and then Jordan Sparks, and then David Cook, and then Chris Allen. How many do we have there? 1, 2, 3, 4, 5, 6, 7, 8. So 2 more to go after Chris. So Lita Wise. And then finally, Scotty McCreary. All right. So I hit enter, right? And on a line by itself, if I do Control D, it will stop the process. And let's take a look inside the directory here. Let's see what we've got now. Whoops, let me do an ls. And here you go. I've got American Idol winners. And let's confirm that it created that file. So now I can use cat again to confirm that what I think is in that file is actually in there. And there it is, right? Okay, great. On to number 9. What will the following command do and why? Right, and the command is uptime, and it's greater than with the pipe, and then do not overwrite my file. Now obviously, if you know the answer to this question, you'll know that the name of the file is a little ironic, because the greater than pipe signifies that even if no clobber is set in my environment, that it's going to override that setting, so it's going to allow me to clobber that file. So if this file exists, it will be overwritten, right? So if I cat do not overwrite my file, there's the time and the date. So let's check to see, right? Is the no clobber shell option set. So if I type in, whoops, I'm going to type in set minus O, apologize. So set minus O, right? So we can see that no clobber is on right now. So if I tried to, if I typed in cat etc password and I try to redirect it into do not overwrite my file and I hit enter, you'll notice it says do not overwrite my file. It says cannot overwrite existing file. The reason it can't do that is because the no clobber variable, shell variable, is turned on, right? And how did we turn that on? Actually, I can just cat out my .bash rc file, and you can see to set that we use a set minus O, standing for turning it on, no clobber. Okay, so it's on right now. So if I were to type in who and then type greater than pipe to do not overwrite my file and hit enter, you'll notice we don't get an error message, and when I take a look at do not overwrite my file, it now has the output of the who command, right? So it did overwrite the file. And again, the reason it overwrote the file is because the greater than followed by the pipe says ignore the fact that no clobber is on and overwrite that file anyway. And sometimes you may want to do that. So again, the following command will overwrite the file irrespective of the fact that you have no clobber enabled. All right, let's clear this out here. Okay, number 10. What will the following command do and why? And so this was an example that they kind of gave in the book. So not a file. So I'm going to redirect output to not a file. I'm going to redirect input to no input there. Oh, misspelled there. And cat. And so what this question is getting you to think about is how things are executed on the command line, right? So it picks up these tokens and it's going to execute them. Even though they're out of order, it's going to rearrange them. The shell will rearrange them, put them into order, and execute them properly. So the cat command would be taking its input from no input there and redirecting it to not a file. So let's see if that works. So if I type in who, and I'm going to redirect it to no input, and I'll spell it properly here, no input there, and hit enter. So now if I cat no input there, I see who's logged on. So now let's run that file, or I'm sorry, let's run that command again, where I do greater than, not a file, less than, no input there, cat, and I hit enter. And you notice we didn't receive an error message. So what do we think happened here? So if I type ls, you'll see the no input there, right? That file's still here, but now you'll notice that we have a new file called not a file. So if we did the cat command and said cat, you're going to take your input from no input there and redirect it to not a file, we would expect to see that whatever was inside this no input there, which we know is the output from the who command, right? Because we created the file here, is going to be redirected into not a file. So let's take a look at that. So if I cat not a file, whoops, not a file, sure enough, there it is. All right, so that's your answer for number 10. Number 11, by default, what is the size of the file in bytes that is created when dev null is used as standard in? So simply put, if I were to use dev null, if I were to say cat/dev/null and put it into new dev null file, and then type ls-lai, my new dev null file is 0 bytes long, right? Because again, remember, it simply overwrites the file. So the answer is 0 bytes. Number 12, it says for each of the following, indicate whether the path name is an absolute path name or a relative path name. And so I'll just walk through each one verbally here. So the first one, ./stuff, that's a relative path name. /stuff, /wow, /Iron Maiden, that's an absolute path name. Stuff/junk/Bon Jovi is a relative path name. .. Again, it doesn't begin with a /, so in this instance, that is a relative path name. The ~bin is an absolute path name because the shell will substitute the value of the home shell variable for that tilde, so that's an absolute path name. F, /home/students is an absolute path name. G /dot is an absolute path name. H /run is a relative path name. /user/bin is an absolute path name, and then J is absolute /path name /, and that is a relative path name. Keeping in mind that if the directories do not, or I'm sorry, if the paths do not begin with a /, they are there, therefore they're going to be relative path names, not absolute. And again, the only case where that is not true is when you use the CD with the tilde, because the shell will substitute the value of the home directory value from the shell and make it an absolute path name. All right, number 13, provide a single command that could be used to append the contents of the following regular files into a single file without using the greater than redirection symbol. So on number 13, it gives you 4 file names, and it wants you to cat out the contents of each of those 4 files and put them into another file, and again, without using the greater than. So let's take a look here. So if I go down into the temp directory, right, and often you can use the temp directory as a scratch area, right, sort of a sandbox. So I'm going to say copy, or let's see, we'll create the file. So we'll do date greater than stuff, and then stuff is a directory. All right, so let me go into dir3, which we created earlier. All right, so date, I'm going to create some files. Create the file stuff, who, put it into junk, uptime, and put that into older stuff, and then let's see, something short. How about another command here? Well, I guess we can cat the etc hosts, or we'll copy etc hosts, and we'll put that file in here, and we'll call it myjunk. All right, so if I were to type in cat stuff junk older stuff and myjunk without using the greater than sign, if I use just the greater than sign, let's see what happens, and I'll call it my file. So if I type ls, you can see I've got a file, my file. So it created the file, but what's the size of that file? 1,839 bytes. So I'll bet if you add up 739 and 999 and 72 and 29 that you're going to end up with just about 1839, if not exactly 1839. Okay, and so we're going to want to check that, right? We're going to want to see what the value of that is. So BC, right, which is basically a basic calculator, if you can think of it that way, will allow me to add that up really quick, right? So here we go. This is free software with absolutely no warranty. So let's find out if it's accurate. So 739 plus 999 plus 72 plus, whoops, back up here, plus 29. All right, what do we get? 1839. You can do Control-C. Oops, I'll just type quit. You use quit to exit out. So as you can see, I quickly added those things up, and it added to 1839. So as we would expect, let's cat out my file. And I'll have to scroll back a little bit. So there is the current system date and time. Right, here's who's logged on. Here's the uptime information we're looking for. System's been up for 115 straight days. And then there's the host file, right? So again, using cat, I can simply cat a series of files and then have that output all go into one file, right? And I can't overwrite the file because, again, no clobber is set. To overwrite it, simply add the pipe after the greater than, and it's overwritten. All right, and that was your answer for number 13. Number 14 says, provide a single command that could be used to move the following regular files into the directory temp. So it simply lists out all of these files. So how would I move these into the temp directory? I could simply use move junk, my file, whoops, or junk will use stuff, I'll use older stuff, and I'll use my junk, right? And then I can give the absolute path name to the temp directory. I could use the relative path name to the temp directory, right? Which is actually the parent directory, so just ... would be good enough, right? But we'll use the absolute, and I think we're going to get an error message here because some of those files already exist. So actually, let me use dir2, right? And so then let's take a look, ls/temp/dir2. And there you go. So you can see in the directory I'm in right now, all of the files I moved, junk stuff, older stuff, and my junk, I put them into dir2 under temp. They're gone from here. So if I cd into temp/dir2, and now do ls-lai to make sure we see everything we can, here they are, right? So again, the premise or the purpose of the question is to get you to think about moving multiple files at one time instead of one at a time, and as long as your last argument on the command line is a directory, all of those files will get moved into that directory. Okay, question number 15. It says there is a file located in the following directory. It's in temp, red, yellow, blue, green. Alright, so let's see what we've got. ls-lai, and it's called colorful. So let's take a look and see what's in colorful. As you would expect, a lot of colors. So how many lines are in this file? Let's say I was curious. I wanted to know how many lines were in this file. I could do cat colorful and pipe it to wc -l. So there's 43 lines. It says provide a command that will display everything in the file except the color purple. And so I could do grep -v purple, and then the name of the file, colorful, right? And that's pulled purple out of there, as you can see. Now I could also do cat colorful and then pipe it to grep-v purple. Oops. And I'll get the same result, but let's talk about this command for a second, because really, as you just saw from the previous command, the cat command's not needed here. I can just simply do grep-v purple in the name of the file. When I do this, right, this will work, and this is a correct answer, but something to keep in mind is that this is actually going to spawn a second process, right, for the cat command. To facilitate the running of the cat command, a second process is going to be spawned to run cat and then to run grep instead of a single process. Obviously, this is not that compute intensive, so it's not going to make it's not going to be a big deal, so to speak, but something to keep in mind, right? And we get the same output. Okay. Question number 16. Provide a pipeline command that would do the following exactly in the order shown. You should have a single command when you are done. And we talked about this, how to attack these pipeline commands, is to run them little by little to see what it is you're seeing, right? So the first thing says, list all the users that have logged onto the system since the last system restart, or since the log that tracks the previous users was rotated. And again, we know that that command is last. Okay, and you can see there's quite a bit of output here, right? And it was actually just rotated on February 21st. Okay? So about 4 days ago, 3 days ago. All right, so we know that the command last shows all the users that have logged onto the system. B says show every line except the lines that have the string CSI135B. Right? So CSI135, so we're going to grep -v, right? So every line except the lines, and that's what that -v means, except lines with CSI135B. Okay, so now let's run it and see what we get. So we take a look over here, and yeah, I don't see any CSI135B user IDs over here. That's correct. All right, so now we're this far down the pipeline, right? So C says, send this output to a file named not_CSI135B. And again, but there's more things we need to do after this. So this is where we want to use the T command, right? So I could use the T command, and we'll append to be sure and send it to not_CSI135B. Okay, and then it says show only the lines with the string CSI135E. And then it says show only the users who have logged on during the month of February. So I would grep FEB, because as you can see we have February here. And then it says show only the users who have logged on Tuesday through Sunday. And so this is to try to get you to think, if I'm asking for Tuesday through Sunday, what's the one day of the week I'm not interested in seeing? And that would be Monday. So grep minus V for Monday. And send this output to a file named TUE-SUN. So let's go ahead and run this. We'll hit enter. Oh, where are we at here? I'm down into a different directory. So I'm going to move into my home directory, right? Because I don't have permissions down in that directory. And I'm going to run the command again. And I should have two files. I should have a file called not_CSI135B, which would be the output of last and then grep minus V on the CSI135B. So whatever this output would have looked like, it will be in this file. And then I've got a file called Tuesday through Sunday that's going to show me users who have logged onto the system in the month of February from CSI135E, but not on Mondays. So if I type ls, do we have not CSI135B? We do. So let's cat that. Oops, not_CSI135B. And sure enough, that file was created at that time, right? And then let's do an ls again. And now let's cat out, pull the command back up here. Tuesday-Sunday, and it certainly created it. There it is, Tuesday-Sunday, right? So Control U erases the whole command line because I don't want to do backspace. And I'll cat Tuesday-Sunday, and there you go. So here's a list of only users from CSI135E who have logged in Tuesday, Wednesday, Thursday, Friday, Saturday, or Sunday, but not on Monday. You'll notice there is no Monday. And the log was just rotated, which is why we don't see anybody from Tuesday or Wednesday, because the 21st, which is when the log was rotated, is Thursday. Okay, so that would have been number 16. Number 17, it says, who is the AACC user? It says, provide the user ID that logs in from an IP address that ends with .149.89. So let's do last, and I'm going to grep for 149.89. All right, there is none. And prior to the log being rotated, I believe it was the user SHS, but the answer here would be none because the log has been rotated. All right, let me clear my screen. Number 18, provide a pipeline command that would do the following exactly in the order shown, right? And this is going to be very similar to number 16. So list all the users that have logged onto the system since the last system restart or since the log that tracks it was rotated. We know that's the last command, right? So I'm going to type in last. Show every line except the lines that have the string CSI135E, right? So we're going to do grep-v CSI135E, and then that's what that output would look like. And again, you can see here the user ID field. There is nobody from CSI135E at this point. Okay? So, show every line except the lines that have CSI135C. So now we're going to grep minus V, and we're going to pull out CSI135C. Show only the lines with the string Vader. And let's see what we get. Whoops. I'm going to grep Vader. Sorry about that. Grep Vader, and there are none, right? So the file is going to be blank. So we're going to T to -A Lord Vader. We want to create a file named Lord Vader. Show only the users that have logged onto the system in January. Send this output to a file named January. So we would tee it up again. And then show only the users who use the Vader system on Mondays. So I would grep Monday and then send the output to Vader_users_Monday, right? And again, there's my Vader users on Monday. We haven't had anybody in there. They just rotated the log. So if I cat Vader_users Monday, it's empty, right? If I cat January, it's going to be empty because we only see people that are logged in February. All right. So number 19 is going to be, if you didn't do this on the night of class, you're not going to get an answer for number 19 because there was one user we were looking for, and that user will not show up from number 18. All right, number 20. What is the size in megabytes of the dev CCISS/C0D0P1 partition? So 20 through 25 or 20 through 24 ask you some information about using the df command, right? To take a look at human readable format. So again, the size in megabytes of the C0D0P1, which would be this, file system right here, right? 99 megabytes. So the answer to number 20 is 99. What is the size in gigabytes of the dev CCISS C0D0P8, which is this partition that has this file system mounted on it? So the size in gigabytes is 19. How much space in gigabytes, number 22, how much space in gigabytes is remaining in the /var file system? So how much is available, right? 16 gigabytes is available. Number 23, how much space in megabytes is available for use in the boot file system? There's /boot, and available is 72 megabytes. And finally, number 24, how much space has been used in megabytes in the /boot partition? And we were just there, so used is 23. So there's 72 available, 23 have been used, so 24% of the /boot file system has been used, and it is on the physical partition C0D0P1. Okay, so you would have compiled all of your answers into a file, and we'll say that our file is memo. Oh, whoops, memo's a directory. Apologize. So we'll say it's see what's in hosts. Hosts is just good enough. We'll use hosts, right? So number 25 says, using the mail program on the System Vader, send me the following files via an email. It asks for your list of answers, the file that you created in number 16, and then the file you created in number 18, which is Vader, and then the file in number 18, January. And that all needs to be done in a single email, not 4 different emails. So here's how you would do that. Mail space -s. Here are my lab number 5 answers. Spell that right. Answers to TPB. Right? Hit enter. You can do ~r, and I'll type in hosts, and it reads in hosts. If I do ~r, I can read another file name in, right? Oops. Do Control U. So ~r and then not _CSI135B. And then ~r space Vader. And there's no such file or directory there. So I'll do ~r January. Right? And again, January is empty because we didn't expect to see anything. And let's see. Yeah, so number 25 should have been Lord Vader. So if I did a ~r on Lord Vader and then hit enter. And again, that's empty as well if you're running it now. So, okay. So that has all been read in. I can go ahead and put the period on a line by itself. I always want to CC myself, right? Because I always want to make sure I'm receiving a copy. So if I type in mail, there it is. If I hit enter, you can see there's my file. Right? So here's all the things that I've sent. Okay. So that pretty much wraps up lab number 5. And again, the hope is that you took the time during class to run these labs, run through the questions in the lab, because you get the most out of it. And again, they've rotated the log, so you're not actually going to see a lot of the things that I was hoping you would see. Okay, that's it for lab number 5, and please be sure to email me if you have any questions. Thanks a bunch, and enjoy the rest of your week.